Welcome to my channel. Today, we'll be diving deep into a crucial network protocol, Address Resolution Protocol, ARP. Is a network communication protocol used to map an IP address to a MAC address within a local area network. Whether you are a beginner or looking to brush up on your networking knowledge, you are in the right place. Let's get started. Whenever a device wants to communicate with another device in the same network, it must know the MAC address of the destination device. Since devices communicate using IP addresses, ARP helps in resolving these IP addresses to their corresponding MAC addresses. How ARP works? Imagine device A, 192.168.1.10, wants to send data to device B, 192.168.1.20, in the same network. Device A knows the IP address of device B, but does not know its MAC address. ARP helps in this process through the following steps. 1. ARP request. Device A sends an ARP request to all devices in the network. This request is a broadcast message with the question, who has IP 192.168.1.20? Tell me your MAC address. 2. ARP reply. Only device B, 192.168.1.20, responds with an ARP reply. This reply is a unicast message containing its MAC address. 3. ARP cache update. Device A stores the received MAC address in its ARP cache table to avoid sending repeated ARP requests in the future. 4. Communication begins. Now that device A knows device B's MAC address, it can send data packets to device B. ARP table. The ARP cache stores recently resolved MAC addresses to minimize network traffic. This table contains IP address, MAC address, type, dynamic or static, time to live for dynamic entries, dynamic ARP entries, automatically learned and deleted after some time, static ARP entries, manually added and do not expire. Viewing the ARP table. Windows, RPA, Linux, Mac, RPN. Types of ARP. 1. Normal ARP. Standard ARP operation used to map IP addresses to MAC addresses in a local network. 2. Gratuitous ARP. A device sends an unsolicited ARP reply to inform other devices about its IP MAC mapping. Used for IP conflict detection and network redundancy. Example, failover scenarios. 3. Proxy ARP. A router responds to an ARP request on behalf of another device in a different network. Used when two devices are in different subnets but appear as if they are in the same network. 4. Reverse ARP. Resolves a MAC address to an IP address. Used in old network systems where devices did not have IP addresses assigned. ARP security issues. 1. ARP spoofing. A hacker sends fake ARP replies to associate their MAC address with a target's IP address. This allows the attacker to intercept, modify, or stop network traffic. 2. ARP flooding. Attackers send multiple fake ARP requests, overloading the ARP table and causing network congestion. 3. MAC spoofing. An attacker changes their MAC address to impersonate another device and gain unauthorized access. Prevention methods. Use static ARP entries for critical devices. Enable dynamic ARP inspection on network switches. Use VPNs and encryption to secure communication. Monitor network traffic with tools like Wireshark to detect anomalies. ARP is a vital protocol for network communication in a LAN. It ensures devices can identify each other using MAC addresses. However, it has security risks like ARP spoofing, which can be mitigated using security measures such as static ARP entries, dynamic ARP inspection, and encrypted communication. By understanding ARP, network engineers, cybersecurity professionals, and IT administrators can optimize network performance and secure their infrastructure effectively. That's all for today's exploration of Address Resolution Protocol, ARP. I hope you now have a better understanding of how ARP works and its significance in networking. If you found this video helpful, don't forget to like, share, and subscribe for more insightful content. Feel free to leave your thoughts or questions in the comments below. Thanks for tuning in, and I'll see you in the next video.